have healthcare, they don't have any sanitation, which means that they have a lot of children, but a lot of them die, and their age expectancy is not very high. Stage 2 is where we start to have healthcare and sanitation. We're still having a bunch of children because culturally that's what we do, but they live for a longer time. So we don't see a big dip or a big death at the very beginning. So we're gonna do like a little fun thing. So everybody go like this. This is stage 1, this is the Hershey kiss. Stage 2 is the pyramid. So you just bump it out. So stage 1, stage 2. Okay, stage 3. I think it looks like a pencil, so go like this. So arms are straight, fingers make a pencil. And I like to remember that it's a pencil because this is due to education. That stage 3 transition is usually happening because women are being educated, we have access to family planning, people are not having as many children. So down here shows you the fertility rate, or how many individuals are being born. So you can see the fertility rate is decreasing, and they're more likely to survive. So stage 1, Hershey kiss, high death rate. Stage 2 is the pyramid. That's where we have high birth rate, but we're actually surviving now. Stage 3 is the pencil, because we're doing education. Stage 4 is the dome. So you just curve your fingers. This is very low population growth because people are just choose not to have kids. There's more elderly in the population than there are young. So looking at our data from Lehigh, pre-1900s, which transition do you think they're in? Do you think they're transition 1, 2, 3, or 4? So talk to your tables. Which transition do you think pre-1900 Lehigh is? Yeah. What do you mean?
I'm just confused as to like what.
We'll talk about that in just a little bit. Yeah, we'll get there. Absolutely. Okay, so for pre-1900 Lehigh, what transition do we think we're in? Which stage do we think we're in? Brooklyn, what do you think? What stage do you think we're in for pre-1900 Lehigh? Perfect. So pre-1900 Lehigh is definitely pre-industrial because we have nothing, right? There's nobody else here. We are building log cabins. There is no heat. There is no sanitation. There is very little healthcare. So I would agree that pre-1900 Lehigh is here. So now post-1900 Lehigh, what stage do you think we're at? She's not here. Hudson, where do you think we're at?
3 or 4.
Perfect, 3 or 4, I would agree. So in between 3 and 4, we're kind of moving from 3 to 4. Because like post-1900, that's where we are right now. So the reason that we're kind of moving over is because we still have like my parents' generation and the generation right above me that are still probably in the stage 3. But all of the newer generations like you guys are probably going to shift over to stage 4. So are there any questions on the things that make each of these stages shift? Like, are we curious about anything? Give me a thumbs up if you feel like you understand what makes everybody advance to a different stage. Give me a thumb sideways if you're a little bit nervous. Thumbs down, you don't understand. So where are we feeling with transitioning from different stages? Everybody has thumbs, so I should see everybody having a thumb up voting. All right, cool. So let's talk about what these actually mean. So demography, or demography, if you want to call it that. This is the study of statistics such as births, deaths, income, or the incidence of disease, which illustrates the changing structure of human populations. And this is why we looked at Lehigh's cemetery data. Because if you look at the backboard, we can clearly see a change in the life expectancy and the lives of people in Lehigh. There is a stark difference. There is definitely a change or a demographic change between pre-1900 and post-1900 individuals here in Lehigh. So we're going to skip that. When we look at age structure diagrams, you might be saying, Dihar, I love that we have the Hershey kiss, the pyramid, the pencil, and the dome, but what does it mean? So when we look at these, what we're actually looking at is we're looking at the number of males and females at different ages. So at the bottom, so right here, ages 0 to 4 is blue. So this would be like, or 0 to 14. So this would be like 0 to 5, 5 to 10, 10 to 15. So these are all the young people in the population. Over here are the males in the population. Over here are the females in the population, which is why it usually looks like a mirror image, because we have basically the same amount of males as females in a population. And as we go higher up, you're going to see different age groups. So as we go higher up in each of these, it should always kind of taper a little bit, because the older you get in different populations, the more likely you are to die. So looking at the big idea, so this is in blue, so you do need to start writing it down. So what does an age structure diagram tell us? Number one, the slope of the shape is the death rate. So the more straight the slope, or the more gentle the slope, I guess I should say, the more the death rate is. Joel, don't make me take your glue sticks away, because I will. And the steeper the slope, the less the death rate is, because the population is not dying off as we go farther in the years. So that's the first thing that we can look at and see from an age structure diagram. The second thing we can tell is fertility rate or birth rate. So the thicker the base, the bigger the birth rate, or the more the fertility rate. So this one, from here to here, has definitely a bigger fertility rate or birth rate than this population, because those are the individuals that are being born into the population. So the base of it is either the fertility rate or the birth rate, whatever you would like to call it.
Hands off, it's done.
Okay. The next thing we can look at is the height. So the height is the life expectancy. So the taller it is, the longer you're expected to live. The shorter it is, the less long you're expected to live. Next, kinks or divots, as I would call them, show dramatic changes to births or deaths. So, for some reason, during these two time periods, we had less people born. Or maybe there's a war going on, and this is the age group of people that are fighting in the war, and so the population is going down. So any kind of divot is showing either a decrease of births or some kind of thing that is making this group more susceptible to dying. And the last thing we can tell from age structure diagrams is the total population. The bigger the area, the more the population. The smaller the area, the less the population. So out of these two graphs, we'll say this is graph A and graph B. Which one do you think has a bigger population?
B.
B, love it, right? This one's a thick boy, not quite as thick of a boy. So this one has a bigger population because it shows the number of people. So down here, this is a 0, and then this, it's really fuzzy, so I can't tell you the number, but it shows the population of people in that age group.
I haven't priced it.
I know, I'm impressed.
It's just standing.
I'm just waiting for someone to hurl a glue stick across the room to make sure it's not standing. That's what I'm looking out for. Joel, leave it alone. You don't need more glue sticks. You already have the corner of the market on glue sticks. I'm so glad this exchange is being recorded for my YouTube channel, so.
Oh, is that on your YouTube channel?
Yeah.
Don't follow me.
So, what does an age structure diagram tell us? Truthfully, it tells us the economic status, either a developing or developed area. So it tells us where are these populations economically. So when a population looks like a pyramid or like a Hershey kiss, they are developing. They still have a high birth rate. when the population looks more like a pillar, they are more developed because the birth rate goes down. So you can see right here, you can see how these groups have developed. So this is the year 2000. In Europe, we have more of a column which tells us that Europe is more developed. You have Africa, which is more of a Hershey kiss shape, which means it's underdeveloped and the population's pretty small. And then Asia, you can see there's a lot of area, but it still has a pretty big death rate, which means that it's still developing as well. But if you fast forward 50 years, Europe looks about the same. Africa, it looks more like a pyramid than a Hershey kiss, which means that we're getting healthcare and we're getting sanitation. And then over here, you can see that it doesn't look like a Hershey kiss at all. It looks like a fat bottom Hershey kiss, which means that the young are surviving and we are having a large population still, but it's getting more developed. Okay, so so when we're looking at this, something that it brings up is the total fertility rate. So what a total fertility rate is, it's the expected offspring each woman is going to have. So the hypothetical offspring number that each person or each female at the reproductive age is going to have. I'm like low-key impressed with all of these without me noticing. Right?
I got it so high.
I know.
One more.
I did take them off. Right here. So when we look at total fertility rate, the total fertility rate in the U.S. is 1.8. So we look at this total fertility rate of 1.8, and this tells us that our population is shrinking. You might be saying, D-Hart, but we're building 1 million houses in Lehigh. Like, how can our population be shrinking? So just because we have people moving into the United States, that's what's keeping the United States population growing. But by those that are here that are reproducing, our reproduction level is below replacement. It's saying that every woman is having about 1.8 kids, which is not enough to replace the guy and the girl in the relationship. So replacement level fertility in developed countries is at 2.1. Am I okay to switch the slide? Yeah. Okay. So replacement level fertility is 2.1. And you might be saying, D-Hart, how is it possible for someone to have 0.1 of a child? So the idea is that individuals are going to die before they get to reproductive age, right? You're going to have kids that die, you're going to have teenagers that die, you're going to have people that die before having kids. So for every 10 females, 1 female is going to have 3 kids, and everybody else has to have 2 kids. That's what the 0.1 means. It means that we need to have a few more offspring than the current population, just so that, this is going to sound so bad, but just so we have like fudge room, we have a buffer for anybody who dies before they can reproduce and add individuals to the population. So this graph over here shows the United States, and it shows the total fertility rate, but this graph is wrong. Because if you look at Utah, Utah is a dark blue number. Wow, that's a color. I can talk. Utah's a dark blue color, right? Right here, which says above replacement fertility. That is not true. Utah is not above replacement fertility. We are actually below replacement fertility. So if I look it up right now, Utah total fertility rate. So as of August 1st, 2022, Utah's total fertility rate is down to 1.9. So 1.92 actually. So we're supposed to be light blue now. Yes?
Would like say a family has like 15 kids, would that affect it at all?
Yeah, that would totally affect it, because what happens is you take the number of births per year and you divide it by how many females there are in that area that are able to have children. And so that's the fertility rate. Joel, we are not promoting teen pregnancy right now. This is not health class, and I'm pretty sure they do not promote it in health class either. So yeah, it would affect it, but if you look at Utah now, most people are having below 2 kids. Like I said before, a lot of my friends that are my age have decided not to have kids. And so, like, I only have 2. I'm thinking about stopping at 2. Maybe there's a third out there, but that's the max. Whereas, like, my family had 4, my mom's family had 5, my dad's family had 7, my mom's family had 12, my mom's dad's family had 9. Like, as the years go by, people are having less and less children, and we're going below total fertility rate or replacement level fertility. So I have a question for you guys. So for a developed country or a developed place, replacement level fertility is 2.1. In an underdeveloped country, do you think the replacement level fertility is higher or is lower? So talk as a team, talk as a table, and then when I count to 3, after I give you time to talk, you're gonna give me a thumbs up if you think that the replacement level fertility is higher for a developing country, or a thumbs down if you think the replacement level fertility is lower in a developing country. So go ahead and turn and talk.
It's higher because there's still like
So in a developing country, do you feel like the replacement level fertility or the number of individuals or number of babies a female has to have is going to be higher to keep the population stable or lower?
How many subscribers do you have here?
I have 0. This is literally just for my students.
I'm gonna subscribe.
Okay, do it.
What's your YouTube channel?
It's just Sarah D. Hart and has a picture of me holding a skull.
I'm gonna
Like this.
subscribe.
Okay, on the count of 3, give me a thumbs up if you think that developing countries need to have more children for their replacement level fertility or less. 1, 2, 3, show me where we're at. Okay, you guys are right. You need to have more offspring. So usually, in a developing country, the replacement level fertility is around 7. That each woman needs to have 7 children in order to keep the population stable. 7.
You have 1 subscriber now.
Oh, sick. All my hopes and dreams just came true. Okay. So, that's all of our notes. That is everything. So let me tell you what we're doing today for the rest of our time together. Something that was requested, let me stop this.